Near the end of the dinosaur age, long after most giants had already risen and fallen, the Earth produced something unusual. For more than 160 million years, dinosaurs had dominated the planet. Entire dynasties had appeared, ruled their ecosystems, and eventually vanished again. Evolution had already experimented with countless shapes, sizes, and survival strategies. And then, in the final chapter of that long history, something extraordinary emerged. Not as the beginning of a new era, but almost as if it appeared too late. A predator built with terrifying efficiency, a design so extreme that it almost feels like evolution pushed itself too far. Today we know this animal by a name that has become legendary, Tyrannosaurus Rex. But before we can understand T-Rex, we have to answer a more basic question. How do we even know dinosaurs existed at all? Because no human being has ever seen one alive. Everything we know about them begins with stone. In the early 1800s, when the first dinosaur fossils were discovered, scientists had almost nothing to work with. They weren't uncovering complete skeletons. They were finding fragments, teeth, pieces of bone, strange shapes trapped inside rock. And from those fragments, they tried to imagine the animals that once carried them. The results were unusual. Early reconstructions showed dinosaurs as enormous lizards dragging their tails across the ground. Their bodies sprawled low, their posture awkward and slow. They were imagined as giant reptiles, heavy, clumsy, and unintelligent. To us today, those images look strange, but they weren't mistakes. They reflected the limits of the evidence available at the time. As decades passed, more fossils were discovered. Skeletons became more complete. Paleontologists began finding trackways preserved in ancient mud, showing how dinosaurs actually moved. Bone structures revealed muscle attachments. Teeth revealed diet. Skulls revealed how these animals sensed the world around them. Each new discovery forced scientists to rethink what dinosaurs really were. Again, and again, and again. Today, paleontology has become one of the most data-rich historical sciences we have. More than 10,000 dinosaur fossils have been discovered, representing over 900 different species. And the story is still expanding. In fact, between 2003 and 2022, scientists identified an average of about 45 new dinosaur species every single year. Not because dinosaurs are suddenly appearing, but because the Earth is still giving up its secrets. Slowly, layer by layer, fossil by fossil. And that matters, because Tyrannosaurus Rex did not appear at the beginning of this story. It appeared near the end. To truly understand it, we have to go much further back. Long before the continents looked the way they do today, nearly all land on Earth was connected into a single massive supercontinent known as Pangaea. A world where oceans did not divide continents. A world of extremes. The interior of Pangaea was dominated by vast deserts. Near the coasts, powerful seasonal storms formed. Deep beneath the surface, volcanic activity reshaped the planet. It was a harsh environment. And it was in this unstable world, around 230 million years ago, that the first dinosaurs appeared. But they were not giants. Early dinosaurs were small, lightly built animals. Many were no larger than modern dogs. They lived in the shadows of other reptiles that dominated the land. At the time, dinosaurs were not rulers of the planet. They were simply one of many groups trying to survive. Then the Earth changed again. Around 201 million years ago, massive volcanic eruptions erupted across what is now the Atlantic region. The climate shifted dramatically. Many dominant reptiles disappeared. Entire ecosystems collapsed. And almost by accident, dinosaurs inherited the world. The planet became warmer and wetter. Forests spread across the continents. Dinosaurs began evolving into larger and more specialized forms. Some became enormous plant eaters. Others evolved into powerful predators. For many people today, this is the era that comes to mind when they think of dinosaurs. The Jurassic. But the Jurassic was not the peak of dinosaur history. That came later, during the Cretaceous period, and it was in that final chapter, when dinosaurs had already ruled the planet for millions of years, that one of the most famous predators in Earth's history finally appeared: Tyrannosaurus Rex. Despite its enormous fame, Tyrannosaurus Rex was actually a late arrival. It did not live during most of dinosaur history. In fact, it appeared only during the final moments of the Cretaceous period, roughly between 68 and 66 million years ago. Geologically speaking, that is a very short time. Dinosaurs had already ruled the Earth for more than 150 million years before T-Rex ever appeared, which makes one small detail quietly ironic. The most famous dinosaur in the world did not live during the Jurassic period at all, yet it became the symbol of a movie called Jurassic Park. It is a mistake that reveals something deeper about how we imagine dinosaurs. Films often compress time, showing species that were separated by tens of millions of years living together as if they belonged to the same world. But the real story is far more complicated. The age of dinosaurs was not one single moment in time. It was a long and constantly changing history. And Tyrannosaurus Rex appeared very close to the end of that history. To understand it, we need to look at the place where it actually lived. About 66 million years ago, North America did not look like it does today. A shallow inland sea cut the continent almost perfectly in half. This body of water, known as the Western Interior Seaway, stretched from the Arctic Ocean all the way down to the Gulf of Mexico. Because of that sea, the western part of the continent became a separate landmass, an island continent. Scientists call it Laramidia. This was the world of Tyrannosaurus Rex. As far as we know, T-Rex lived only here. Most of the fossils we have discovered come from a region of rock known as the Hell Creek Formation, which stretches across parts of Montana, North Dakota, South Dakota, and Wyoming. When paleontologists dig in Hell Creek, they are not just finding T-Rex. They are uncovering an entire ecosystem, a complete world frozen in time. And that world looked very different from our own. Imagine a vast floodplain filled with rivers weaving through thick forests. The climate was warm, humid, and heavy with moisture. Rain fell frequently, and the land was covered in dense vegetation. There were no grasslands. Grass had not yet spread across the planet. Instead, the ground was covered in ferns, and forests were filled with conifers, magnolia trees, sycamores, and early flowering plants. Palm trees grew along the riverbanks. It was a lush, crowded landscape, and it was full of life. One of the most common animals in this environment was Triceratops. Those three-horned herbivores were everywhere. In some fossil beds, they make up nearly 40% of the large animal remains. Herds of them likely moved slowly through the forests, grazing on vegetation. Another common animal was Edmontosaurus, a duck-billed dinosaur that traveled in large groups. These animals could grow over 12 meters long and probably moved in herds so large that the ground shook beneath them. Then there was Ankylosaurus, a low-slung dinosaur, covered in armor plates, carrying a massive bone club at the end of its tail. For a predator, attacking one of these animals would have been extremely dangerous. Smaller dinosaurs lived among them. Pachycephalosaurus, with its thick, domed skull. Thescelosaurus, a modest herbivore moving quietly through the undergrowth. Various small raptors and bird-like dinosaurs hunting insects and small prey. And beneath all of them, mammals already existed. But they were small, tiny creatures hiding in burrows or moving through the leaf litter at night, staying out of sight of the giant reptiles that ruled the land. Their time had not come yet. The rivers of Hell Creek were also full of life. Crocodilians drifted through the water. Turtles basked along the banks. Fish and even sharks moved through waterways connected to the inland sea. It was a fully functioning ecosystem, dense, complex, alive, and at the very top of this world stood Tyrannosaurus Rex. This predator was not a rare accident. Fossil evidence suggests that tyrannosaurs made up a surprisingly large portion of the large predator fossils found in the region. That means T-Rex was not just a legend glimpsed once in a generation. It was an established part of this ecosystem, a regular presence, the apex predator of Hell Creek. And among all the Tyrannosaurus fossils ever discovered, one individual has become the most famous. Her name is Sue. Of all the Tyrannosaurus Rex skeletons ever discovered, one stands above the rest. Her name is Sue. In 1990, fossil hunter Sue Hendrickson was exploring the Badlands of South Dakota when she noticed something unusual sticking out of a cliff. It was a bone. At first glance, it didn't seem extraordinary. Fossils appear in these formations all the time. But as excavation began, it quickly became clear that this discovery was different. Very different. What they had found was one of the most complete Tyrannosaurus Rex skeletons ever discovered. Around 90% of the skeleton was preserved. For paleontologists, this was extraordinary. Most dinosaur fossils are incomplete puzzles made of scattered pieces. But Sue was something else, a rare opportunity to study an entire animal in remarkable detail. Today, Sue is displayed at the Field Museum in Chicago, where millions of visitors stand beneath her reconstructed skeleton. But Sue's bones tell a story that is far less peaceful than the museum lighting suggests. Her skeleton is covered with injuries. Deep bite marks scar her skull. Several ribs show clear signs of fractures that healed during her lifetime. Some of the bones in her tail fused together after trauma. There are even signs of disease, including what scientists believe may have been infections and possibly gout. Sue lived a violent life, and she survived it. These injuries matter because they tell us something important about Tyrannosaurus Rex. Being the top predator did not mean living in safety. Even the king of this ecosystem faced danger. Other predators existed. Rival tyrannosaurs may have fought each other for territory or food. Prey animals like Triceratops were heavily armed and capable of defending themselves. Every hunt carried risk. Every confrontation could leave scars. Sue's skeleton is not just a collection of bones. It is a record of survival. A life spent navigating one of the most dangerous ecosystems that has ever existed. And when we imagine Tyrannosaurus Rex today, we often picture it standing alone on an empty landscape. A cinematic image, a single giant framed against the horizon. But that is not how it lived. T-Rex lived in a world that was crowded, noisy, and constantly moving. Forests full of herbivores, rivers filled with reptiles, predators competing for territory. Life was everywhere, and Tyrannosaurus Rex stood at the top of it all, not as a monster from myth, but as a real animal, living inside a fragile ecosystem that had been evolving for millions of years. An ecosystem that, without anyone knowing it, was nearing its end. Because only a short time later, something would happen that would erase this entire world. Now that we understand the world Tyrannosaurus Rex lived in, we can finally look at the animal itself. And the first thing anyone notices is the size. A fully grown T-Rex stretched about 12 meters from nose to tail, roughly the length of a city bus. Its hips stood nearly 4 meters above the ground, and its body could weigh somewhere between 6 and 7 tons. That is heavier than most elephants alive today. But size alone does not explain why Tyrannosaurus Rex became one of the most successful predators in Earth's history. Many dinosaurs were large. What made T-Rex different was how every part of its body worked together. Start with the skull. The head of a Tyrannosaurus Rex was enormous, more than one, 5 meters long in the largest individuals. But it wasn't simply big. It was engineered for force. The bones of the skull were thick and reinforced with ridges that distributed stress during biting. Instead of being light and flexible like the skulls of many predators, the T-Rex skull acted more like a massive crushing frame. And then there were the teeth. They were not thin blades designed to slice like a knife. They were thick, conical spikes, some more than 30 centimeters long, including the root. These teeth were built to punch through bone. Computer simulations suggest that Tyrannosaurus Rex could bite with a force somewhere between 35,000 and 57,000 newtons. To understand how powerful that is, consider the strongest bite among animals alive today. A saltwater crocodile can produce around 16,000 newtons. T-Rex could generate more than double that. It didn't simply tear flesh. It crushed entire bones. Paleontologists have found fossils of prey animals with T-Rex bite marks punched straight through solid bone. Some bones even show teeth embedded so deeply that the predator literally shattered the skeleton during the attack. And we know Tyrannosaurus Rex consumed those bones as well. Fossilized droppings, called coprolites, contain fragments of partially digested bone. That means when T-Rex ate something, it consumed almost the entire body. Nothing was wasted. But strength alone was not what made this predator so dangerous. Tyrannosaurus Rex was also built to detect prey long before it attacked. Its brain reveals this clearly. CT scans of T-Rex skulls show extremely large olfactory bulbs, the part of the brain responsible for smell. In fact, this region is proportionally larger than in almost any other known dinosaur. That suggests Tyrannosaurus Rex had an extraordinary sense of smell. It could likely detect carcasses or living animals from long distances, possibly kilometers away. Before a prey animal ever saw the predator already knew it was there. Vision was another powerful advantage. Unlike many reptiles whose eyes face sideways, the eyes of Tyrannosaurus Rex faced forward. This created overlapping fields of vision between the left and right eyes. In other words, binocular vision. The same system used by modern predators such as hawks, owls, and humans. This gave T-Rex the ability to judge distance precisely. Some studies even suggest its visual acuity may have rivaled that of modern eagles. If you were standing still in front of a Tyrannosaurus Rex, hoping it would not see you, you would be very mistaken. It would not just notice you, it would see you clearly. And hearing may have been another advantage. The inner ear structure of T-Rex suggests it could detect low-frequency sounds extremely well. Deep vibrations, footsteps, the distant rumble of a herd moving across the floodplain. This predator was not blindly wandering through forests. It was gathering information constantly. Smell, sight, sound, all working together to locate prey. And then there is the detail people always ask about. The arms. Yes, Tyrannosaurus Rex had very short arms compared to the rest of its body, but they were not useless. Far from it. The bones show large muscle attachment points, meaning the arms were extremely strong. Each arm may have been capable of lifting more than 200 kilograms. The claws were thick and curved, capable of gripping and holding struggling prey during close encounters. They may not have reached the mouth easily, but they were powerful tools when the predator was already engaged in a fight. In other words, nothing about Tyrannosaurus Rex was accidental. Every part of its body, the skull, the teeth, the senses, even the arms, formed a system designed to locate prey, overpower it, and survive in one of the most competitive ecosystems that had ever existed. There is one sound everyone associates with Tyrannosaurus Rex: the roar, a deep, thunderous scream that shakes the ground and echoes through forests. It has appeared in nearly every dinosaur movie ever made. But the truth is, we don't actually know what T-Rex sounded like. In fact, the famous cinematic roar is almost certainly wrong. Tyrannosaurus Rex did not have a larynx like mammals do. The closest living relatives of dinosaurs today are birds and crocodiles, and neither of them produce sounds the way lions or bears do. Instead, they create deep vibrations through air sacs and throat structures. Crocodiles produce low, booming calls that travel through water and land. Large birds, such as cassowaries, create deep rumbling sounds that humans can sometimes feel more than hear. If Tyrannosaurus Rex made any sound, it may have been something similar. Not a scream, more like a deep rumble, a vibration that carried through the air and ground. Something you might feel in your chest long before you understood what was making it. But another debate about T-Rex has lasted even longer than the roar question. Did it hunt? Or was it only a scavenger? For decades, scientists argued about this fiercely. Some researchers believe Tyrannosaurus Rex may have relied mainly on scavenging. Its powerful sense of smell could easily locate carcasses across large distances. But most paleontologists today agree that the evidence points to something else. Tyrannosaurus Rex was most likely both. An opportunistic predator. If it found a carcass, it would eat it. If it encountered weak or slow prey, it would hunt. This behavior is common among modern predators. Lions, bears, and crocodiles all do the same thing. Nature rarely wastes energy, and Tyrannosaurus Rex was built to take advantage of any opportunity. Another detail people often wonder about is the skin of T-Rex. For many years, dinosaurs were imagined as scaly reptiles. Later, discoveries of feathered dinosaurs in China revealed that many small theropods, the group that eventually produced T-Rex, were covered in feathers. This raised a fascinating question. Was Tyrannosaurus Rex also feathered? The answer appears to be complicated. Early relatives of T-Rex clearly had feathers, but skin impressions discovered from Tyrannosaurus Rex and its close relatives show something different. Pebbled, scaly skin. This suggests that adult T-Rex individuals were likely mostly scaly, not fully feathered. However, scientists cannot rule out the possibility that juveniles had some feather-like coverings early in life. As they grew larger, those coverings may have disappeared. It is another reminder that dinosaurs were not simple reptiles. They were complex animals evolving across millions of years. And there is one final detail that surprises many people when they see a Tyrannosaurus Rex skeleton in a museum. The skeleton is not entirely real. When paleontologists excavate dinosaur fossils, they rarely uncover a complete skeleton. Instead, they find scattered bones buried across rock layers. A skull here, a rib cage somewhere else, pieces missing entirely. To display a full skeleton, scientists must reconstruct the missing parts. They compare fossils from multiple individuals, mirror bones digitally, and sometimes create casts of missing elements. The mounted skeletons you see in museums are therefore part fossil, part reconstruction. But modern paleontology is extremely precise. Most museum reconstructions today are estimated to be about 99% accurate to the real animal. Even so, every T-Rex skeleton still contains a little bit of imagination, a puzzle assembled from fragments, a reconstruction of a creature that disappeared 66 million years ago. And yet, when people stand beneath one of these skeletons, something powerful happens. They look up. They imagine the animal alive. And for a moment, the distance between our world and the deep past feels just a little bit smaller. When you stand beneath a Tyrannosaurus Rex skeleton in a museum, there is a moment that almost everyone experiences. You stop, you look up, and for a second, it's difficult to understand what you're seeing. The skull alone is larger than your entire body. The teeth are the size of kitchen knives. The ribs stretch outward like the frame of a collapsed building. It is a creature that seems almost impossible. But the skeleton above you is not just a scientific display. It is a story. Every fossil is a fragment of that story. A bone preserved in stone. A piece of an animal that lived, hunted, and died 66 million years ago. And when paleontologists assemble those bones into a full skeleton, they are doing more than reconstructing anatomy. They are rebuilding a lost world. Because humans don't experience history as disconnected facts, we experience it through stories. When you see a Tyrannosaurus Rex skeleton, you are not just seeing bones. You are seeing an animal that once walked across forests and floodplains. An animal that breathed the same air our planet still produces today. A predator that lived in a world so distant from ours that it almost feels unreal. But there is an uncomfortable problem behind these fossils. A growing number of Tyrannosaurus Rex skeletons are no longer found in museums. They are being sold. In 1997, the famous skeleton Sue was auctioned for $36 million before being purchased by the Field Museum in Chicago. At the time, it was the most expensive dinosaur fossil ever sold. But that price changed the fossil market forever. In 2020, another Tyrannosaurus Rex skeleton known as Stan sold at auction for $31.8 million. The buyer was anonymous. For a long time, scientists did not know where the skeleton had gone, and that creates a serious problem. Fossils are not just valuable objects. They are scientific evidence. Each bone contains information that researchers use to understand how these animals lived. The microscopic structure of the bone can reveal growth patterns. Chemical signatures inside the fossil can tell scientists about diet and environment. Injuries and diseases preserved in the skeleton can reveal behavior. When a fossil enters a private collection, scientists may never be able to study it again. The information it contains becomes inaccessible. Today, dozens of Tyrannosaurus Rex fossils are held privately rather than in public museums. Some are displayed in private homes. Some are kept in storage. Some may never be studied again. And every time that happens, a piece of Earth's history becomes harder to understand. Because these fossils are not just rare objects. They are pages from the story of life itself. When a child walks into a museum and stands beneath a Tyrannosaurus Rex skeleton, something remarkable happens. They see a creature that lived tens of millions of years before humans existed. They realize that the history of life on Earth is far larger than our own. That moment cannot be measured. It is curiosity, wonder, a connection between the present and the deep past. Tyrannosaurus Rex was one of the final great predators of the dinosaur world. A creature shaped by millions of years of evolution. A hunter that ruled its ecosystem until the very last moments of the dinosaur age. And then, almost instantly in geological terms, its world disappeared. 66 million years ago, an asteroid struck the Earth. The impact triggered global fires, darkness, and ecological collapse. Dinosaurs that had ruled the planet for more than 160 million years vanished. But the story did not end. Some of their descendants survived. Small feathered dinosaurs that we now call birds. They are the last living link to that ancient world. And when we look at them today, we are not just seeing animals flying across the sky. We are seeing the final survivors of a world that once belonged to giants. That if you enjoyed this journey into the deep past, consider leaving a like and subscribing to the channel. There are many more stories from Earth's ancient history still waiting to be explored.